See these question numbers 19 and 20 of exercise 7.2. Here, they both look similar, but here are very different. Okay, exercise 7.2. First, we are going to do question 20, which is looking more bulky, but the easier one is question 20. Why is it easier? Look here. What is the derivative of e raised to the power 2x? Ishita, derivative of e raised to the power 2x?
2 into e to the power 2x.
Yes, e raised to the power 2x into 2. Now tell me, Ishita, again, what is the derivative of e raised to the power minus 2x?
Minus 2 into e to the power minus 2x.
Because of these two, if you take this complete denominator as u, what is going to happen? You see, if you take u as the complete denominator, you also do with me these two steps that we have written, you can rub off. We are going to use those two derivatives because the derivative which you said is available in the numerator. How is that? You see, first of all, substitute e raised to the power 2x plus e raised to the power minus 2x as u. Let u equal to e raised to the power 2x plus e raised to the power minus 2x. Then the derivative, the first one, e raised to the power 2x derivative is 2 into e raised to the power 2x. Then e raised to the power minus 2x into minus 2 into dx. We have differentiated it. But you can see there is an extra 2, this extra 2 coefficient that is not there in the numerator. So what do you do? Du by 2. Make it du by 2. Take that 2 to the denominator. Du by 2 equal to e raised to the power 2x minus e raised to the power minus 2x dx, which is what we have there in the numerator. Therefore, the whole of integration we can rewrite as what? Kushi, tell me the step, Kushi. By giving this substitution, what will this become?
dt by 2t.
Du by 2. See, this whole thing is du by 2. Good. Du by 2. 1 upon 2 we keep outside. And what is inside, Kushi?
U upon u.
1 upon u. Very good. So what is the integral of 1 upon u?
Log mod u.
Log mod u. But this 1 by 2 was already there. Keep it there and plus c. Now, lastly, we replace that u. Replace the u, that is half of log of e raised to the power 2x plus e raised to the power minus 2x plus c. So, the whole of denominator's derivative was easily available there. That's how we did this question. Completed it, Ishita? Going to the next question. Yeah, okay. So, देखो, in question 19, this way, if you take the complete denominator as u, what's going to happen? The derivative will be 2 into e raised to power 2x, the numerator, one term is okay. But what about the second one? Derivative of 1 is not 1 in the numerator. So we cannot go directly like that. But we are going to make this equation, this expression somehow in this pattern. What is that somehow? Dekho to, I'll tell you. You will divide the numerator and denominator by e raised to x. Divide the numerator and denominator by e raised to the power x, which means the step will be now integral all the numerator and denominator e raised to 2x minus 1 e raised to 2x plus 1. These are the terms we have. But I'm telling you, divide by e raised to the power x. Each term you are going to divide by e raised to the power x. Divide by e raised to the power x. What is the benefit of it? What has it become? ये देखो तो What is e raised to the power 2x upon e raised to the power x, Ishita?
E raised to the power x.
Yes, power subtracted. Now, what about the next one? What is 1 upon e raised to the power x? E raised to the power minus x.
Minus x.
Yes. And in between there was a minus. So, same thing will happen in the denominator also. E raised to the power 2x upon e raised to the power x is e raised to the power x plus 1 upon e raised to the power x is e raised to the power minus x. Yes. Look, has it become something like this? The question number 20, it has become similar to that. So what do? Take the substitution. U equal to the complete denominator, e raised to x plus e raised to minus x. This whole thing is taken as u. So then what is the u? That is e raised to the power x minus e raised to power minus x dx, which is the numerator. So exact, without even a half. In this question, in the question number 20, there was a 1 by 2. Here, a complete numerator is ready, du. So 1 upon u du. Therefore, the integration is log u, log mod u, and replace the u. I'm giving you solution of both of these questions with printed steps. You can copy, you can cross-check your answers. First one was e raised to power 2x plus e raised to power minus 2x substituted. When you differentiate, 2 is extra. So half of 1 by u du, log of mod u, and half of log of u is being replaced. Whereas in question number 19, we divide by e raised to the power x. See, how is the division done? Numerator and denominator both we have divided by e raised to the power x. Then it becomes e raised to power x is the first one. Next one is, the second one is e raised to power minus x. Therefore, the complete denominator now we can take a substitution so that the derivative is the numerator. So 1 by u du, log mod u, then replace the u. So similar looking questions, but they were very different questions. We have to make it into the second form. Shall we go to the next one? Question 21. Okay. Integral of tan square 2x minus 3. Kushi, Ishita, who is going to remind me, how do we integrate tan square x function? We have done it in the standard forms. Tan square x.
X square x minus.
Exactly. We have used it twice earlier. Sec square x minus 1. This is identity, trigonometric identity. Tan square x is sec square x minus 1. Like that, this question also change it into sec square, the angle is 2x minus 3 minus 1 dx. That minus 1 is a separate term and that 2x minus 3 is the angle. Ab bolo, Ishita, what is the integral of sec square 2x minus 3? What is the integral of sec square function? Ishita?
Ma'am, tan x.
Tan x na. So what should be the answer here? This step, first step.
Tan 2x minus 3 by 2.
Upon 2. Very good. This we have practiced the other day, the direct shortcut. Okay. What is the integral of the second term, Ishita? Integral of 1 minus of
Ma'am,
1. Yes. Then that's all. This is the answer. Integral of tan square 2x minus 3. Completed, children? Okay. Going to the next one, question 22. Oh, just sec square function only directly. Ishita, oh sorry. Kushi, bolo. What will be the integral? Directly answer it in one step.
Uh, tan 7 minus 4x upon
Yeah.
4
Upon minus 4.
minus 4.
Yeah, plus c. That's all. Straight away, sec x, sec square function, integral is tan x function. That's it. There we are at question 23. What is this? Which name? Very simple one. It's only looking too bulky. All that root x and all na given deliberately by the hand. Dekho. Try to recollect. Root x key derivative is 1 upon 2 root x that we can see. Dekho, 1 upon 2 root x ka 2 is missing. That is okay. That we can cross multiply with du. Another interesting thing is derivative of tan x is sec square x. ये देखो sec square is present, tan function is present. So both of these we will make use of. Okay, dono. No need to give it as separate substitution. We will give it in one step. You take the substitution tan of root x. Take tan of root x as the substitution. Don't take the power. Only u equal to tan of root x. Okay. Kushi, what is the derivative of tan of root x, Kushi?
Sec square root x into 1 by 2 root x.
Sec square root x into 1 by 2 root x. Very good. Into dx. Now what happens? Look in the question. The only extra thing is this 2. Rest everything is there. Sec square root x is there. 1 upon root x into it. Dx is there. The 2 is missing. So what do? Cross multiply that 2. 2 du is equal to sec square root x upon root x into dx. 1 upon root x go to upon root x complete. So we can easily rewrite our function. Because sec square root x upon root x into dx is there. That we will replace as du. Therefore, integral 2 du. Keep the 2 outside and du here. And what's the other thing? Is it u raised to the power 4? Tan root x is u. Ishita, what will be the answer now?
Ma'am, in terms of u,
Yeah, in terms of u, you have to write once. What is it?
ma'am, u to the power 5 upon 5.
Plus c. Integration is over, but we need to write in terms of x. So it's equal to 2 into u was tan root x. Tan root x to the power 5 upon 5 plus c. This is the answer. After completing the integration, you should always rewrite the function in terms of the original variable given to you. That was question 23. I think in new editions, question 23 is given as another question. You can check. This was the question as 23 earlier, so I did like this because when I prepared this slide, this was the question given as question 23. Question 23, I think you see in the question book as sine inverse x upon root of 1 minus x squared. Is it correct, Ishita? Is it the one given as question 23?
Yes, ma'am.
All right. So you take the my question 23 as an additional question, extra question. This also used to be there in the book. Now, Suno bache, you can take u as sine inverse x. It is because what is the derivative of u, Ishita? Or what is the derivative of sine inverse x?
Ma'am, 1 upon root 1 minus x square.
Exactly. Which is what we have here, yellow. 1 upon root 1 minus x square into dx is there. Therefore, what will this step become? Integral u into du and nothing else. Sin inverse x is u. And rest the whole thing is du. Above. Integration is u square by 2 plus c, that is sine inverse x whole square by 2 plus c. This is the answer. That is question number 23. The earlier one also is question number 23. Write it as additional question. You can write 23 star. Yes, bacho. Going to question 24. Yeah, look at this. Copy the question below. 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x. Okay. Copy the question. Now solve. Here these coefficient 2 and 3 in the numerator, 6 and 4 in the denominator, they are deliberately given with some particular connection. What is the connection? मैं बता देती हूँ. What is the derivative of 6 cos x? 6 cos x. What is the derivative? Minus 6 sin x is the derivative. And what is the derivative of 4 sin x? The derivative will be plus 4 cos x. So, if you take this complete denominator as u, du will be minus 6 sin x plus 4 cos x. What is the use? There is a big use. That is, see, we have differentiated. Now, if you observe here, 2 cos x minus 3 sin x. 2 cos x minus 3 sin x. And instead of 2 cos x, we have 4 cos x. Minus 3 sin x, we have minus 6 sin x. So if you take a 2 common from here, that will be same as this numerator. So if you take minus 2 common, what is it coming? Minus 3 sin x plus 2 cos x into dx. So only extra thing is that extra 2. So this is what now du. Therefore, du upon this 2 you take down equal to this bracket. No harm if you write the first term pale. First term negative term second. That is 2 cos x minus 3 sin x dx. ये देखो, this whole thing is already given here. ये देखो, this one. Therefore, we can rewrite it as, can you say, Kushi, what you will rewrite it as? Kushi, you
by
complete thing as u it was taken. So the denominator is u, and then what?
du upon
Du upon 2. Du upon 2. Because the numerator, that complete thing is du upon 2. That is what you observed here. This is du upon 2. Here it is. And that upon 2 we can keep outside. So it is half of integral 1 by u du. And what is integral 1 by u du? Log u na? So half into log u mod u plus c. So we can rewrite it as half into log mod 6x plus 4 sin x, 6 cos x plus 4 sin x. This way we can leave the answer plus c. Now in this question, children, what happened is these coefficients were very good, well matching. But try to imagine, what if instead of this 3, if it was a 5 sin x? What if instead of this 4, if it was a 7 sin x? Some other coefficients. Even then, we can do this question. For that, I'm going to show you a generalization. Are you ready for the generalization? In this question, those coefficients were given well matching. Okay, watch it. Very easily it was given. 3, its double is 6. Then 2, its double is 4. What if they don't match like this? And still the question is of the form a sin x plus b cos x upon c sin x plus d cos x with any a, b, c, d. This a and b, anything. Then how will we do? Shall we do the general method, Bacho? Say something. Let me
Yes, ma'am.
see that you are there. Okay. This general method I'm showing you and the context of that question. That question was particular one. Chalo, all of you copy this question. A general method सिखाने जा रही हूँ. General method, which is applicable for any A, B, C, D coefficients on sin x and cos x. When the function is linear expression of sin x and cos x, both in the numerator and in the denominator. What we do is, we will try to change the numerator as this denominator's derivative. In the previous question, realize that's what happened exactly. When we took this as u, the denominator as u, we had its derivative in the numerator, only some constant was missing, isn't it so? The 2 was missing. So we wish this numerator to be the derivative of the denominator. How is it possible? So the method goes this way. Let the numerator be equal to a constant into denominator plus another constant into denominator's derivative dash. We want this pattern. Write down this. What is the pattern we use? Numerator equal to dr means denominator. A into denominator plus b into denominator's derivative. Dash dalawe means derivative. Denominator's derivative. So we need to change the numerator in this pattern. What is the numerator? This is the numerator. So this is general method. I'm going to take an example, numerical example, and do it. This is the procedure we will apply. Take an example. What is A, B, C, D? Ab dekho to. You can see A is 2. This is the one. B is 5. This is the one. C is 3. Yellow. D is 1. Here it is. Okay. So A, B, C, D are given in such a way that they are not just double or triple or anything. There is no interconnection. So we need to go for this method. Chalo, take it to the sideboard. Let the numerator be equal to A into denominator plus B into denominator's derivative. Ye dekho, numerator equal to, numerator is this one. This whole thing as it is equal to A into denominator. Ye dekho, denominator is written here. Ye this one. This is as it is copied here. Plus B into denominator's derivative. Is it actually the derivative? Check karo. 3 sin x ka derivative is 3 cos x. Cos x ka derivative is minus sin x. Yahan derivative to hai. Denominator's derivative, denominator as it is, and denominator's derivative in the second one. After letting this, pehle to let kar lo, we don't know whether it was going to be possible. Let this first. Have you written the step till here, bacho?
Yes, ma'am.
Yeah. Now we need to calculate the values of A and B. We need to get their values. How? Dekho, we have got an equation, a trigonometric equation. For this trigonometric equation to be equal, coefficient of sin x on the left side and coefficient of sin x on the right side should be equal. Also, coefficient of cos x on the left side should be equal to coefficient of cos x on the right side. That means Like terms coefficient should be equal on both sides. So अब लिखो equating coefficients of like terms. We are going to equate the coefficients of like terms. Only then this equality will prevail. Otherwise that equality will not be true. So equating the coefficients of like terms. सबसे पहले let's take the coefficient of 2. Sorry, coefficient of sin x. What is coefficient of sin x on the left side, बच्चे? 2 है ना? Okay. Ishita, look at the diagram and tell me sin x का coefficient क्या होगा? If you open this, first of all, it will be 3a, 3a,
Yes, ma'am.
and also what next?
Minus B sin x.
So 3a minus b, this much time sin x is on the right side, whereas 2 sin x we have on the left side. No need to write these sin x. Don't write. We are only equating the coefficient. So equate it. We get 2 equal to 3a minus 3b. 2 is equal to, which is the 2? This 2 equal to 3a minus b, this one, minus b. This is one equation. Now equate the coefficients of cos x. On the left side, we have 5 times yellow. And on the right side, a into 1 and b into 3. So a plus 3b equal to 5. We have equated the like terms. अब पता है क्या करना है? आपको ये दोनों equation solve करना है. Simultaneous equation solving. Tell me, how are you going to solve it? This is equation number 1. This is equation number 2. Solve karo a and b. Should I multiply the second equation by 3? Or should I multiply the first equation by 3? Which is easier? Which one do you want to do? Both are easy. Bolo ji.
First by
First one
3.
multiply by 3. So what is equation becoming? 6 equal to 9a minus 3b. And the second equation as it is, copy karo, 5 equal to a plus 3b. And why did we write both of these equations? Are we going to add them? Ye dekho, minus 3b and plus 3b becoming 0. 9a plus a is 10a. 10a is equal to what? We have added it, okay? 6 plus 5 is 11. So what's the value of a? 11 upon 10. A मिल गया. Now what is b then? I think we can go from the second equation. From the second equation, 3b is equal to 5 minus a. That is 5 minus 11 by 10. That is 10 is the LCM, 50 minus 11. That is 39 by 10. Therefore, b is 39 by 10 and you are dividing by 3 also. What is it now? 13 by 10. We got the values of a and b calculated. This is b and a is this one. Is it okay, bache? 11 by 10 and 13 by 10.
Yes.
Solving is done. We have got a and b values. What is the use of it? Ye dekho, we have solved and got the value. A is 11 by 10, b is 13 by 10. So this numerator is going to be rewritten now. Ye dekho, this integration we are going to make new. Integral of denominator is the same. 3 sin x plus cos x. This as it is we keep. Whereas the numerator is no more than just 2 terms that we are going to rewrite. What is it going to be? A into, A is 11 by 10. 11 by 10 into, this one we copy here. Then plus 13 by 10 into, which one do we copy from there? The second one over here. Copy it. We are writing that expanded form. This is the step. A is 11 by 10. This A we are using here. Then B is 13 by 10 that we are using. And using that, we are copying these two over here. So no numerator, that is the original numerator is no more there. This is not there. That's gone. Why did we do so? एक second बच्चों. If you open it now, you can see it's the same thing. ये देखो. Shall we expand it and see? Don't expand, okay? Expand करेंगे तो पता क्या होगा? You will get back to this step. With great difficulty, we have created it. Don't simplify and reach back. Don't go behind. Don't go backward, okay? अगर खोलोगे तो यही आ जाएगा. You want to see? This is, if you expand, don't write it, okay? 11 by 10 into 3, that is 33 by 10 x. 33 by 10 sin x. And here, how many sin x there? Dekho, minus 10 by, sorry, 13 by 3, 10 sin x. So how much sin x is there? You are multiplying by 3. First one, 3 into 11 by 10 is 33 by 10 sin x. And 13 by 10 into minus 1 is minus 13 by 10 sin x. Sin x common karo and 10 LCM kar. What is happening? 33 minus 13 upon 10 sin x. What is 33 minus 13, bache? Isn't it 20?
Yes, ma'am.
Upon 10 is 2. This 2 is what we have split up like this. No need to cross check. You can straight away go. Why did we do like this? It is because we wish to rewrite it. Ye dekho, the denominator we are going to give to both of those terms separately. This we give here, also we give here. Make it into 2 terms. Separate it into 2 terms. Why? What is the benefit? Ye dekho, the whole thing is cancelling the 2 factors. So the first term is only this much, integral of 11 by 10 dx. Ho gaya. Plus, in the second one, we are going to use the denominator as u. You will take this as u equal to 3 sin x plus cos x. Then the du, we have already created the du in the numerator. Derivative करके देखो. It is 3 cos x minus sin x into dx. This is what written in the numerator. So Ishita, tell me, Ishita, what is the second step going to be if you give the substitution?
Ma'am, 13 by 10 integral of 1 by u du.
Exactly. So we can complete the integration just in one step now. This is it. Khushi, what is integral of the first term, beta? इसको integrate करवा दो.
11 by 10 into x.
Very good. Second one also आप भी बता दो.
13 by 10 into log
And what is the u?
u is 3 sin x plus cos x.
Very good. Okay. So this is the general method. It is applicable with any constants A, B, C, D. So let's do a new question now. I'm giving a new question, not of the textbook. See, you know, children, in between, I keep giving you extra questions, not of the exercise book. But you will see on the way, they will all be there somewhere or other in your textbook only. Okay? So I'm not importing and I'm not just burdening you. Look at this question, bache. Integral 1 upon 2 plus 3 tan x. Write this question. If this question as it is comes in the paper, you will wish to have a substitution tan x. but which will not work. Can you tell me, Bache, why this substitution will not be good for this question?
And the derivative is not there.
Exactly. The derivative sec square x तो हमारा है ही नहीं, so don't use it. Then what? Okay, you're going to see the interesting thing. You will never think the question is going to be like this. ऐसा करो, सबसे पहले sin x and cos x conversion कर. The tan x is going to be written in terms of sin x and cos x. What is that, Kushi? Change the tan x as in terms of sin x and cos x. What is that? Tan x is equal to, Kushi?
Sin x
Sin x upon cos x. So 3 into sin x upon cos x. अब आप LCM करो. Take the LCM. What is going to be the LCM? We are doing everything in the denominator. Cos x is the denominator. So 2 cos x plus 3 sin x dx. This whole thing is the denominator. Can you tell me what will this step become? What new simplification can happen on this, Ishita?
Cos x can be taken to the numerator.
So what will it become?
Cos x upon 2 cos x plus 3 sin x dx.
Yes, 3 sin x dx. Right till here, cos x upon 2 cos x plus 3 sin x. बच्चे पता है, just now I told you a generalization. What was the generalization? If you get an integrand in the form a sin x plus b cos x upon c sin x plus d cos x बोला था. Is it applicable here? What is a, b, c, d if it is possible? A sin x is missing. So what is the value of a? A 0. B cos x के जगह है तो cos x. What is the b here बच्चे बताओ?
1.
1. What about c now? C sin x.
3.
3. And the d is 2. ये देखो, it is perfectly in this pattern. One of them is 0. कोई बात नहीं. The numerator, one of them is 0 is okay, no problem. Still, that generalization method is applicable. Okay. So, let's continue. What was the method? What you should do? Change the numerator. Let the numerator be equal to a into denominator plus b into denominator's derivative. So what equal to? What is the numerator? Cos x now? So what do I write? Cos x equal to a into what? Who is going to tell me a into what? The method says a into denominator. What is the denominator?
2 cos x plus 3 sin x.
That is what we should give here. 2 cos x plus 3 sin x. And what is the second bracket going to be? Denominator's derivative. Denominator we have copied. Now denominator's derivative should be here. What will come there? Bolo. Minus 2 sin x plus 3 cos x. Is it going okay, bachcho?
Yes, ma'am.
What should be the next step? Equating the coefficients of like terms. I'm waiting for both of you to write till here. Once over, let me know.
I'm done.
So what is the next step, beta bolo? How will you find the values of A and B? Write down there, equating the coefficients of like terms. Equating the coefficients of like terms, which means coefficient of sin x on both sides, coefficient of cos x on both sides. Bolo ji. First, let us equate the coefficients of sin x on both sides. How many sin x do we have on the left hand side?
0.
0 equal to. How many sin x you have on the right side?
3a minus 2b.
3a minus 2b. Okay. And what about the cos x? On the left side, how many cos x? 1. And on the right side, cos x dekho to 2a plus 3b. Now we need to solve these two equations. How do we solve, bache? Do we need to make the coefficients equal? If yes, batao, which coefficient you will make equal? Fishy. Solve karwa de these two equations.
We can take A equals to 2B by 3.
A is equal to, you want to eliminate 3a is equal to 2b and all that. I think it's better you multiply by some number and make the coefficient same, na?
Okay.
First one I'm going to multiply by 2. Second one we are going to multiply by 3. So what are the equations? 0 equal to 6a minus 4b. Second one is 3 is equal to 6a plus 9b. Up subtract karo. Minus 3 equal to minus 19b. So b is equal to 3 upon 19.
Ma'am, 13.
Oh sorry, 19 क्यों लिखा? Oh sorry, 13 ही तो है. 9 देखे 19 कर दिया. It is 13 only, I'm sorry. हाँ जी, 4 and 9, 13, 3 upon 13. And a is equal to what? Put that b there and get the a. Where will you put? We can go and put in any of them. A is equal to 2b upon 3. So 6 upon 2 into 3 upon 13 upon 3. That's going to be 2 by 13. Is a 2 by 13 coming? 3a is equal to 2b. This is correct. Then, why did we do all these? After completing this side work, how do we change it now? We change the integration. The numerator cos x is now going to be written as a into, what is the a? 2 by 13. 2 by 13 into denominator plus 3 by 13 into denominator's derivative. Since you have already calculated this AB, I'm going to rub off this so that your working will look better. This calculation I'm going to rub off. So next is using this A and B, change it. What do we change? Ye dekho, we have got the A calculated. This is the A value we got. And this is the B value we got. And what should we copy there? Cos x, 2 cos x plus 3 sin x. And the second one, minus 2 sin x plus 3 cos x. Where is it from? From the assumption that we have made. We wanted to change it like this. Not only A and B. We are rewriting this one. This denominator is coming here. And this denominator's derivative is coming here. What for? अब इसका whole denominator भी तो है ना. 2 cos x plus 3 sin x dx. Now we will separate this into two integration. You can skip the steps, of course. Lot of steps you can skip. It's not necessary to write it so elaborate. Integral. The 2 by 3 we can keep outside. Is equal to what comes now? 2 by 3 is the A. Inside the integral, what comes now? The numerator and denominator say here these two should get cancelled now. So 2 cos x plus 3 sin x upon 2 cos x plus 3 sin x dx. Here the whole thing will get cancelled, the first one. Then plus 3 by 13, second one. Integral. There we have the denominator's derivative we have already created, where 2 cos x plus 3 sin x in the denominator. And we have already created this here in the numerator. We have, what is it? Minus 2 sin x plus 3 cos x. Why did we do so? It is for in the first one this get cancelled. So we can directly write it as 2 by 3 integral 1 dx plus 3 by 13, 2 by 3, 9, 2 by 13. 3 by 13 integral. Denominator you take u, we have already created the du in the numerator. What are we taking u as? U is this denominator. This is the u. Numerator we have already created its derivative over there. Therefore, coming to the last step, do the integration. 2 by 13 integral of 1 is x plus 3 by 13 log of u plus c. That is 2 by 13 x plus 3 by 13 log of, what was the u? 2 cos x plus 3 sin x plus c. That's an answer. In fact, this is one question of your textbook. Abhi, from the exercise questions in 7.2 itself, look into the textbook. Which do you have a question 1 upon 1 minus tan x? Which question number are you looking in the textbook also? Do you have a question 1 upon 1 minus tan x? Do you have a question 1 upon 1 plus cot x also? Question number 33? No, 18. Ishita. Look in the textbook, 7.3 exercise. Oh, sorry, you are in 7.2. Do you see that question there? Here I did it in a more generalized example. I took the coefficients 2 and 3. When you have 1 upon 1 minus tan x also, you will convert into sin x and cos x, and you will change it into denominator's derivative and denominator. Going to another question. Question 25. Here, As we have seen many times, 1 upon cos square x can be written in the numerator as sec square x. Karo? It is equal to integral 1 upon cos square x you change as sec square x dx, and the denominator we keep as it is upon 1 minus tan square x. And why we keep it so? We're going for a substitution. U equal to tan x. क्योंकि du derivative is sec square x dx, which we are already given. This is the sec square x dx. It's already there. So the integration is rewritten as it's equal to integral du upon 1 minus, oh, it was 1 minus tan x whole square. Question is 1 minus tan square x, 1 minus tan x whole square. So in the substitution also we could have taken 1 minus tan x. Then also the derivative is the same. So the denominator is therefore now straight away u square. Du upon u square. We integrate it by taking the u to the numerator, u raised to minus 2 du. That is, integration is now, what is integration? U raised to the power minus 2 plus 1 upon minus 2 plus 1. And what is minus 2 plus 1? Minus 1 na? U raised to minus 1 upon minus 1 plus c. U raised to power minus 1 means 1 upon u is equal to minus 1 upon u plus c. That is minus 1 upon 1 minus tan x plus c. Since there is a minus 1, we can write it as 1 upon tan x minus 1 plus c also. Both are correct. That was question 25. Moving on to question 26. Take the substitution. This root x, angle root x. U equal to root x. And the derivative du is 1 upon 2 root x dx. You have 1 upon root x dx here. This is it. So we don't want that 2 over there. So 2 du equal to 1 upon root x dx. So the integration can be rewritten as cos u into 2 du. Keep the 2 outside. 2 into integral of cos u du. Integral of cos u is sin u. 2 into sin u plus c. Therefore, the answer is 2 into sin root x plus c. That's all. That was question 26. A very simple substitution. But realize one thing. Though we took the root x as the substitution, both of them were not the u. One of them was u, the other one was used as du. Remember, it's a very simple question. Question 27. Root of sin 2x into cos 2x. Two factors. Go with a substitution, only sin 2x. Don't take that root. Don't take that root. क्यों नहीं? Why we shouldn't have taken root also in the substitution? Because du is sin 2x ka derivative cos 2x into 2 dx. Differentiated. And you can see cos 2x into dx is given in the question. So therefore, it is du by 2. Substitution we are going with du by 2 equal to cos 2x into dx. Therefore, the integration now changes into root of u into du by 2. That by 2 we are keeping outside. Integral of u raised to the power half plus c, that is equal to half into u raised to the power half means integral will be half plus 1. U raised to the power half plus 1 upon half plus 1 plus c. That is half of u raised to the power 3 by 2 upon 3 by 2 plus c. 2 upon 3 by 2 means 2 will be reversed. What's happening now? 1 by 3 only left. U raised to the power 3 by 2. U is sin sin 2x raised to the power half 3 by 2 plus c. This is it. That is question 27. Question 28. Here, inside the under root 1 plus sin x, you take a substitution. U equal to 1 plus sin x. Q. It is because the derivative of 1 is 0. 0 plus sin x. Sin x ka derivative is cos x. And notice that we are given there. Cos x into dx is there, no? So that is du. So what is the integration changing it into? Yellow. Equal to integral. Denominator is now root u into du. 1 upon root u. 1 upon root u means the power of u is minus half. Now what is integration then? U raised to power minus half plus 1 upon minus half plus 1. Formula plus c. And minus half plus 1 is plus half. U raised to half upon half plus c. That is 2 into root u plus c. That is 2 into, what is root u? 1 plus sin x plus c. That's it. This is question 28. Going further, question 29. We should be familiar with these formulas. Cot x ka derivative. If you want to differentiate log sin x as derivative, if you want to differentiate log sin x, what comes? We have derived integral of cot x as log sin x also. This relation you should remember only then it will, the method will strike you. So here I am giving you the substitution. Take u equal to log sin x. Log of sin x. Q. Because derivative will be then 1 upon sin x into sin x की derivative जो है cos x. अब आप देखो तो this is what? Nothing but cot x. So cot x into dx. We have it now. ये देखो cot x into dx is there. That is du. So the integrand is now u du, nothing else. Nothing else. Which is u square by 2 plus c. And the u is log sin x. Log of sin x whole square by 2 plus c. That was question 29. Going to question 30. This also very simple substitution. Complete denominator 1 plus cos x, you take a substitution. So that du is 0 minus sin x. Derivative 1 is 0, that's why I said 0. Minus sin x is the derivative of cos x. But we have there sin x dx. Therefore, minus du equal to sin x dx. Therefore, the integration is changed into minus du and 1 upon u. 1 upon u is log u integral minus log u plus c. And there is some simplification further, which is minus log modulus u plus c. Minus means minus 1 into. And there is a property n log a equal to log of a raised to the power n. So this minus 1 will go as power minus 1. So log of u raised to the power minus 1. U raised to the power minus 1 plus c. What is log of u raised to power minus 1 means 1 by u. So log of 1 by u plus c. We can leave it like this also. And give the value 1 plus cos x. In place of u, put 1 plus cos x. Okay. Children, I will stop the class now because going ahead like this is really, really boring. I know Ishita and Kushi are listening and proceeding. Why I was not asking questions is because I know you are writing also. It can reduce the speed. That is why. And only you two are there. So I don't feel like doing more. We'll stop now. Okay. We'll continue in the next class.
Thank you, ma'am.
Thank you, ma'am.